Yeah, what's good, y'all? Link here. And let's go for another daily LeetCode question. Question 2016. Maximum difference between increasing elements. All right. Daily 2016. Easy one. Let's see if this is actually an easy one. Okay. Given a zero index integer array nums, okay, of size n, find the maximum difference between num.xi and num.xij. Okay, num.xij is minus num.xi, such that it's gonna be in order. Yep. So I has to come before j, and nums and xi must be less than nums and xj. Okay. Return the maximum difference. If no such I and j exists, return -1. Okay, so the so from what I understood here is pretty much we have to find two indexes that give us two elements that has a difference greater than zero. It can't be zero, right? So in this case, we have 71. This is not valid. Oh, it can be anyone. It can be like, oh, it can be 7 and 5, for example. In this case, not, but yeah, it can be 1 and 10. Okay. Uh, okay. Okay. Let's see. Return the maximum difference. Okay. We have to find two index ij where the numbers index I and j has to give us the maximum difference, and the difference cannot be less than or equal to zero. Okay. Uh, so this case, there's no such element because okay. Let's see this case. This case, we would do 1 and 5. Let's see. What we can actually do here is okay, so we start with the maximum difference will be resolved from the difference between the maximum and the minimum element that follows this rule right here, right? So what we can do here is track the minimum element, and as we walk through the array, we take the difference and update the like a best variable. And once we find a element that's less than this one, we update this element and then keep going and update the max. So in this case, we would have 1, this is the minimum, minus 5, this is 4, update for 4, the best, and then we go to 2, uh, this is 1, doesn't update the max, so let's see. Okay, I think that might work. Let's try to code this real quick. So n is equal to the length of nums. Okay. We're gonna have like a best is equal to, so we can't have 0, right? So we can just put 0 right here. Um, okay, okay. Let's actually do -1. No, 0 is fine. I think 0 is fine. And then we can have a current max is equal to num index 1, 0 actually, right? And then for I in range of 1 to length of nums, we're gonna update our best. Let's see. So what we're gonna do first? We want to update the best first and then update the current max, or we're gonna do the opposite. So in this case, let's say this was a let's say this was a 2 and this was a 1. So we have 2 and then we start here. Uh 2 minus 1, that is -1. Okay. And then we update. Okay, so we want to update the best first. Yeah. So best is equal to the max of best, and we want the next one. So nums index I minus current max. Okay, and then also current max is equal to the max of current max, and then nums index I. At the end, we're gonna return if best is greater than 0, return best. Actually, we can just do return the mm, if best greater than 0, then return best. Else return -1. Because then we don't have an answer for this. Oops, forgot to use the end right here. Just create. Okay, let's see if this one works. Oh, 71. We have a 1, so 1 and oh, 71. This give us yeah, 71. This give us -6. So this is not. We have a new best, so we look at this one as the best. How we go for? Oh wait. Oh, that's fine. Yeah. We could have had 7, so we compare with 1. That's not good. So go here. Now 1 is the best. Oh, it's not the max, the minimum. Sorry. Oops. There you go. So it shouldn't be current max, right? Current min. Or min. And then, oops, right here as well. Okay. Okay, let's see. Give it submit. All right. Not that bad for today, I think. Yeah. Kind of like a, I think it's pretty much a DP approach. So yeah, I think that's all I have for you guys today. I'll see you guys later.